Okay, so let's talk a little bit about how linked lists work. Hopefully you've seen my video on classes. Okay, so I'm just gonna hide this for a second. Okay, so let's talk about how does a linked list work. So basically, if you've ever dealt with a list before, basically, like you've usually got some data 1, 2, 3, 4, 5, right? And then this is a list in Python. But if you've ever wondered, like, how does that actually work? Like, how does the computer know where the next number is in memory? Well, so it's actually usually implemented by something called a linked list. So let's say that we have each one of these pieces of data kind of out by itself. 1, 2, 3, 4, and 5. Now, each piece of information here needs to kind of know about where the next piece of information is, right? So if you look here, basically a linked list kind of gets drawn like this a lot of times. A box, right, with like a little arrow here, with like a circle that kind of goes to the next thing. So this, in a sense, is like how I always visualize a linked list. And anytime you're dealing with a linked list in an interview, you usually want to sort of draw it out to be very similar to this idea, right? So a linked list is like the baseline implementation of any kind of sequential data structure. And the idea is that you just store two pieces of information. This piece of information is your data, and this piece of information is usually called next, right? And it tells you kind of where is the next thing to go to. So let's think about like how would we actually put that together in code? Well, for that we're going to need a class because we kind of need a couple of different pieces of information. So basically, if we do this, we say class linked list. Okay. We need linked list, but we also need another class called node, right? And node has some information. It has a piece of data, and then it also has a reference to the next node. So next, I'm gonna say is none, so that nodes start with a default value for next, and then data equals none. And then we're going to override that with a constructor function. So def init, right? And then self comes in here, but we also need data. So to set this up, I can say self.data equals data. And so now my node has a default setup for next and a setup for data, right? And so it can know what the next thing is. So now in order to, let's say, use my linked list, I'm going to basically say ll equals linked list. And I'm going to pass in a few pieces of information that I want to keep in a list, okay? And then basically what I need to be able to do is have an init function. Init def init. And then it'll take self, but it'll also have to take, and I'm going to use this thing called args. And that's basically all the arguments that are in this function call. So it just kind of puts them into a list called args. So now I can say for, now I can say, so for arg in args, and then what I'll need to do is add these things to the linked list. Now there's an important thing you'll have to keep track of called self.head. And self.head is going to be, it's going to be a node. So args of 0. But I want it to be a node. So node, and then I'll just pass in args of 0. So that's going to be 1. So 1 is going to be our head node. And you always want to have a head node in a linked list. Otherwise, you can't get to the data. And so now for arg and args, and actually I want to start at 1. And start at 1 there. And so then I want to say self dot add args arg. So we haven't created this add function or this add method yet. So I'm going to go ahead and just create this add method. And I'm going to show you how a linked list is iterated over by using this head method. This add method. So def add, and then what I'm going to do is self and node or element. And then what I'm going to do is say current node equals self.head. You will recognize this pattern a couple of times. So current node equals self.head, and then while current node dot next is not equal to none. So while we haven't reached the end, current node equals current node dot next. Okay, so until we get to the end, basically, until we find a node that doesn't have, it's not pointing at anything, change the current node to whatever the next one is. So once you get to the end, though, that's where we want to add something. So we say current node dot next equals node element. So we'll create a new node, and then we will assign the next element. So now we can add all the elements, and then I can run this, and it will complain about my syntax. Self, comma, data. There we go. So now that runs, but we have no way of knowing what's going on with this linked list, right? So let's also create a function that will show us how many nodes there are in this list. So I'm going to add this, and it's not going to be counting over the nodes. I'm going to show you how to kind of use a class to keep something memoized or keep a value up to date. So when I initialize my linked list, I'm going to say self.length. And I'm actually going to use the underscore method length so that nobody gets confused and uses this. So for every element in self.length, or for everything where there's like a self.length, I'm going to say args, if args of 0, self.length equals 1. And then every time I add one, not in here, but instead in here, I'm going to say self.length equals 1. So in this way, I'm basically keeping track of how many times I've called the add function. So then I'm going to create a function that says, or what I'm really going to do is go down here, and then I'm going to say print ll.__ length. And so now it says linked list object has no attribute length. Okay, So that means that it doesn't want me to use that. So that's fine. I'm going to create a method, def length, and then it's going to take self. And then I'm going to say self return self. And then I'm going to print length. I'm going to print the call to length. And that's 6. So then if I add another one, I get 7. And then if I call ll.add 8, then I should get 8. Okay, so I'm able to keep a variable up to date, but you also saw that if I use these underscores, Python pretends like it doesn't know what you're talking about. Underscore length. I've never heard of length. And that's kind of how you tell Python, hey, this variable should not be being touched by things outside of myself. This is sort of for internal use only, and not, not for other people to be like messing with. Because otherwise, I might be able to say ll.length, equals 11, and that isn't true, right? So I can say, print. And now that'll come out 11, right? So we don't want that. And so long as we don't manually try to set ll.length, Python will just pretend again that it doesn't know what you're on about. Okay, so that's how to kind of create a linked list, right? We've got to have our node class to hold on to next and the data. And then we've got to have our linked list class, which knows things about itself. It knows what the head is, the top node. It knows like how to add things to itself. And right now I'm using this method to keep track of the length. Now that's just to say so that we don't have to like loop over the whole thing to get the length. But if you wanted to dynamically get the length rather than relying on this, because this is kind of brittle. You saw me change this to 11, and so it's not very friendly to being super sure that this hasn't been tampered with, right? So if you want to figure out how to use dynamically get the length, well, it's going to be very similar to how this add method works, where we say current node equals self.head, and then we basically just update the current node over and over again, right? So to just kind of see this again, there we go, screen sketch, do it. So, we have like our linked list, right? And then our linked list has this, 1, and that's our head. Okay. And then our head knows about the next few elements, right? And so what we do is, so our 1 knows about our 2, and our 2 knows about our 3. So we say current node, right here, we say current node equals self.head. So now current node here is pointing here. And then so we say while current node dot next is not equal to none. So this is next, and this is data. So since next is pointing to something that isn't none, what we're going to do is we're going to take current node and move it here. And then on the next iteration, we'll move it here. But at that point, current node dot next is going to be equal to none. And so this is pointing to none. Once we get there, then we say current node, which is this, dot next is a new node. And so then we create a new node. And then we change where this points to here, and then this points to none. All right. So that's linked lists, and that's kind of looping over linked lists. Check out the next video for how to solve some of these other issues with linked lists.